Okay, now we're going to learn how to draw orbital diagrams for our electron configurations. So on these we're going to write out the long hand method of electron configuration. So let's do that first. So we've got number of electrons for magnesium is 12. And now we're going to write the configuration for magnesium. So he would be 1s2, 2s2, 2p6, 3s2, and we're not going to need these, so just leave those blank. Okay, so what is an orbital diagram? It is just a picture representation of my configuration. Okay, so we're going to put 2 electrons in the 1s, 2 electrons in the 2s, 6 in the 2p, and 2 in the 3s. So we're going to draw electrons, and we're going to represent electrons by arrows. Okay, so I'm just going to have an arrow going up and an arrow going down. Why is that? Well, there's a few rules you have to follow, and I had you write them down in your notes, but they're also on this back page back here. Here's our 3 rules. Off bow says we're going to put our electrons in the lowest energy first. So that just means we're going to fill up the 1s before we go to a 2s. Okay, each orbital contains 2 electrons. So we're going to represent an orbital either by a line, a box, or a circle. So I can only fit 2 electrons in each one of those. And if it has 2 electrons, they have to be in opposite spin. So I represent that by an arrow up and an arrow down. That's why you see that. This is opposite spin. And then we'll talk about Hund's rule here in a moment. Okay, so let's go back to this page. So I'm going to draw arrows for magnesium. So I'm going to put 2. And again, it's arrow up, arrow down. Here the 2s needs 2, arrow up, arrow down. The P needs 6, so I'm going to go up, 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 down, 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 and then the 3s has 2 electrons. And there we go, we've got 12 electrons total, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there's our orbital diagram for magnesium. Okay, so don't forget to do your configuration and do the orbital diagram. Okay, let's look at one where we're going to have Hund's rule, and I'm going to write here Hund's. So this is going to be an example of Hund's. Okay, so phosphorus is number 15, so he's got 2, 2, 6, 2, and then he's got 3 in the 3p, because he's right here. Okay, this is him, he's 3p, number 15. 3rd electron level, p block, 3rd position. Okay, so 1s is full, 2s is full, 2p is full, 3s is full. Okay, so here's where this Hund's rule comes into effect. It says we're going to fill up the empty orbitals before we share. So I call it like the bus rule, like you're getting on the bus. You're going to fill up the empty seats before you have to share a seat. So we are always going to go 1, 2, 3. We're not going to share. And these are all going the same direction, so we call this parallel spin, whereas these are in opposite spin. This is in parallel spin. Okay, this would be the correct configuration. So if you did this and you put arrow up, arrow down, arrow up, there are 3 electrons, but because of Hund's rule, we would say this is wrong. Okay, so it's just up, up, up. So like even if you're in a 3D, let's look at one. Who's one that would be in the 3D? I'm trying to think. Let's say we had, like here we had iron. He's in the 3D. So when you put those electrons in there for the 3D, you'd go up, 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 up. Then you would share this last one here. Okay, I hope that makes sense. Up, 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 and then down. Okay, so fill in your configuration, fill in your arrows. Okay, on the page after that, that's where you've got these rules here, and you're going to look down here, and all you have to do is tell me which rule is being violated. Okay, is it Aufbau, Pauli, or Hund's? And why is that? So something is wrong with each one of these. So look at them carefully, figure it out. Let me know if you have any questions.